The setup for the problems in exercise 2, 6.5 is really quite similar to the setup for the problems in exercise 1. However, in exercise 2, 6.5, there are a couple of additional twists along the way. We begin the problem in the exact same fashion as we did compared to exercise 1. We begin by writing out the problem horizontally, but you'll notice here that the problems aren't standard argument formation. In other words, there is no conclusion here. What we're doing in exercise number 2 is just simply comparing a group of statements. In the test, unlike in exercise 1 where we were testing for validity, in exercise 2 we're testing for consistency. Nonetheless, write it out horizontally, and then instead of assuming the argument to be invalid, we're assuming that these statements are in fact consistent. So to assume that they are in fact consistent, we will define each respective statement as being true by writing a T directly underneath the main logical operator of each respective statement. So in this particular problem number 1, we've got 3 statements, and again, we'll assume that they are consistent by defining each of them as being true. So from here, the order of solving the problem is just the same as it was in exercise number 2. Given this assumption that they are in fact these statements consistent, we want to know if we can figure anything else out. Can we figure out the value of the remaining variables as well as the remaining operators? And just as we were in exercise number 1, we're concerned with whether or not we arrive at a contradiction, whether or not we arrive at some sort of inconsistency. If we do arrive at a contradiction, then our assumption can't be the case, because again, it arrives at a contradiction, it leads to a contradiction, therefore it would be inconsistent. If no such contradiction is reached, then our assumption is correct. The statements are in fact consistent. So given the assumption that they're consistent, what else can we know in problem number 1? Can we know anything further about premise number 1, or statement I should say, number 1? Well, the main operator is a triple bar. We've assumed it again to be true, but there are 2 ways for a triple bar to be true. Where both sides are true, or conversely where both sides are false. So we can't know anything immediately there. And in a similar fashion, we can't know anything immediately about the third statement. The operator here is a horseshoe. We've assumed it to be true. But again, there are 3 ways for a horseshoe statement to be true. However, we can know something immediately about the second statement. The main operator here is the dot. And by consulting your truth table, you'll see that there's only one way for a dot statement to be true. And that's when both of the conjuncts are true. So here we can immediately know something about the K. We know that the K must be true. And in a similar fashion, we know that the value of not R, must be true. Not that R is true, but the value of not R is true, which of course would make R false. So we figured out the second statement in its entirety, and this has given us quite a bit of additional info to work with. Every time K appears, we can put a T directly underneath it. Notice here that I placed the T directly underneath the K and not under the tilde. And further, we can know that R is false. So every time R appears, one more appearance, I pencil in an F. So now that we know the value of K and R respectively, the same question applies: what else can we know? Given that K is true, we know that not K must be false. So can we now figure anything out about the value of N? We've got question mark horseshoe F being true. So that tells us that M must be false. Otherwise, we'd have T horseshoe F, and that of course would go against our original assumption. So every time M appears, we can now pencil in an F. And that just leaves us now with the first statement to resolve. Here we've got F wedge F, of course would be false. That's a special case for the wedge, which leaves us with T triple bar F. T triple bar F, aha, this goes against our original assumption. T triple bar F would of course be false, as the values here are different. However, we've assumed it to be true, so there is our contradiction, there's our inconsistency. What does that tell us? Well, it tells us again that our original assumption cannot be the case. We originally assumed the statements to be consistent by defining each of them as being true. That assumption led to a contradiction, and so we know that the statements are inconsistent.